Hey everyone, and welcome back for another deep dive. Today we are going to be looking at how drone technologies are revolutionizing the construction industry.
It's pretty amazing stuff.
It is, and specifically we're talking Lidar and RTK.
Two powerful tools.
Yeah, so you might be out there prepping for a meeting, or maybe you're trying to get up to speed in the field, or maybe you're just super curious about these technologies.
Right.
Either way, we're going to break it down for you. We're going to cover what they are, how they're different, and most importantly, why it matters to your construction projects.
Exactly.
So let's kick things off with Lidar.
Okay.
Yeah.
Well, LiDAR stands for light detection and ranging.
Okay.
And essentially, it's a way to measure distances using lasers.
Okay.
So kind of like a super precise radar system.
Okay.
So a LiDAR sensor on a drone sends out these laser pulses.
Mm-hmm.
They hit the ground and they bounce back.
Okay.
And by timing how long it takes for each pulse to return, we can figure out the distance to that point
That's interesting.
and create a 3D map.
I know we've talked about LiDAR before, but the idea of creating a 3D map with lasers, it's still pretty cool.
It is cool.
And it's more than just a cool visual, right?
Absolutely.
These maps have practical uses in construction.
LiDAR's big advantage is that it creates these incredibly detailed 3D point clouds,
Okay.
which are basically massive collections of data points
Mm-hmm.
that represent the shape and elevation of everything the laser hits.
Okay.
So think of it as like a digital twin of the construction site.
Right.
It gives us a blueprint of not just what's there, but also what's under the surface.
And that's something that traditional aerial photography can't really do, right? Especially in areas with a lot of trees or thick vegetation.
Right.
LiDAR can literally see through that stuff and create a clear picture of the ground below.
Exactly. That's why LiDAR is so valuable for construction projects, especially in areas with, challenging terrain.
Okay.
For example, if you're planning a housing development on a site with uneven ground,
Right.
LiDAR can help you see exactly how the land slopes.
Mm.
You can identify any potential drainage issues before you even break ground.
So instead of spending weeks out there with, traditional survey equipment, you can get a comprehensive picture of the site in a fraction of the time,
Right.
like X-ray vision for the ground.
Yeah, exactly.
And it's not just about seeing what's there, it's what that information lets us do, right?
Right. LiDAR isn't just about pretty pictures, it's about data.
Okay.
So for instance, imagine you're clearing a wooded area for a new building.
Okay.
LiDAR can map the height and density of the trees,
Uh-huh.
which can help you plan the clearing operations more efficiently.
Right?
You can even use it to estimate the volume of timber
Wow.
or identify any potential hazards like unstable trees.
So instead of, relying on estimates and risking worker safety with extensive ground surveys, you have this precise data-driven understanding of the site before you even set foot on it.
Yeah.
That's going to be a huge advantage in terms of safety and efficiency. So speaking of efficiency, how does LiDAR stack up against those traditional surveying methods in terms of cost and time savings?
So one study found that using LiDAR for surveying can reduce project timelines by up to 80%
Wow.
compared to traditional method.
80%.
Yeah.
That's incredible.
And that translates to significant cost savings.
Yes.
Sometimes tens of thousands of dollars depending on the project size and complexity.
Wow, 80%. That's a pretty compelling argument for using LiDAR.
Yeah.
And that's not even considering the added safety benefits.
Right.
Okay, so we've talked about using LiDAR for creating these terrain models and mapping vegetation. What are some other practical applications of LiDAR in construction?
Well, LiDAR is also used for inspecting infrastructure like power lines and pipelines,
Oh, wow.
especially those in remote or hard-to-reach locations.
Right.
So using drones equipped with LiDAR,
Mm-hmm.
we can safely and efficiently inspect these assets
Okay.
and identify any potential issues before they become major problems.
So LiDAR is like having an extra set of eyes,
Yeah.
maybe an extra set of highly precise laser eyes to ensure the safety and integrity of our infrastructure.
Exactly.
Now, I know we've been focusing a lot on LiDAR.
Yeah.
I don't want to forget about our other contender in this little technology matchup we have going on here,
Of course not.
real-time kinematic technology, or RTK.
Yeah.
We've discussed RTK in previous episodes, but can you give us a quick recap for those who might be new to the concept?
Yeah. RTK is all about achieving super accurate GPS positioning.
Okay.
It utilizes a base station which transmits correction data to the drone in real time.
Mm-hmm.
And this process eliminates the usual GPS errors
Okay.
and provides accuracy down to the centimeter level.
Wow.
It's like having a superpowered GPS system just for your drone.
And we're talking about centimeter-level precision,
Yeah,
which is pretty mind-blowing when you think about the scale of most construction projects.
absolutely.
But how does RTK stack up against LiDAR? Are they both just different ways to achieve the same goal, or are there some key differences we need to understand?
Well, that's an important point to highlight.
Okay.
While both technologies are essential in construction for precise mapping,
Mm-hmm.
they each have strengths depending on the project needs.
Okay.
And one of the most fundamental differences lies in the type of data they collect.
Okay.
So RTK primarily focuses on positional accuracy,
Okay.
meaning it's great for getting those precise coordinates, latitude, longitude, and elevation.
Okay.
And this information is key for tasks like surveying and boundary mapping.
So RTK is like a super accurate GPS system,
Yeah.
giving us those precise coordinates.
Mm-hmm.
LiDAR, on the other hand, provides that detailed 3D model of the environment.
That's right.
So they both offer precision, but in very different ways.
You got it.
And those differences in data lead to different ideal use cases.
Right.
So RTK is perfect when precise location data is crucial,
Mm-hmm.
such as when you're measuring stockpiles of materials or monitoring construction progress.
Right.
You can even create orthomosaic maps with RTK,
Yeah.
which are high-resolution aerial photographs that have been corrected for any distortions.
Exactly.
Okay, so RTK gives us precise location data and those corrected aerial images.
Mm-hmm.
LiDAR gives us those amazing 3D models.
Yeah.
But how do we know which one to use for a specific project?
Right.
It seems like there's some overlap in their capabilities.
Sure. So choosing between LiDAR and RTK really depends on your specific project needs.
Okay.
So, for example, if you're working on a relatively flat and open construction site
Okay.
where precise measurements are crucial,
Mm-hmm.
RTK might be the ideal choice.
Okay.
You could use it to track the progress of earth-moving operations,
Mm-hmm.
measure the volume of materials,
Okay.
and ensure everything is being built according to plan.
So for a relatively straightforward project where you need those precise measurements and maybe some aerial photos,
Yeah.
RTK is a good option.
Exactly. Now, let's imagine a different scenario where LiDAR might be the better choice. So let's say you're planning to build a road through a densely forested area.
Okay.
The terrain is uneven, vegetation is thick,
Right.
and you need to assess the feasibility of different routes,
Mm-hmm.
considering things like slope stability
Mm.
and the potential environmental impact.
That sounds like a much more challenging project.
It is.
How would LiDAR help in that situation?
Well, in this case, LiDAR becomes essential because of its ability to see through the tree canopy.
Right.
So with LiDAR, you can create that detailed 3D model of the terrain,
Uh-huh.
which allows you to analyze the different route options with much greater accuracy.
So even before sending in ground crews, you have a solid understanding of the challenges and opportunities presented by the terrain.
Right.
That could save a lot of time, money, and potentially even prevent accidents.
Exactly. And that ability to see beneath the surface
Yeah.
is why LiDAR is so valuable for pre-construction surveys in general,
Okay.
especially when you're dealing with challenging terrain.
So we've established that LiDAR and RTK offer these distinct advantages for construction projects.
Right.
They both sound incredibly valuable.
They are?
But I also know that any new technology comes with a price tag.
Of course.
Can we talk about the investment required for both LiDAR and RTK systems?
Sure. It's true that both technologies require specialized equipment,
Mm-hmm.
which means an investment is involved.
Yeah.
LiDAR, because of the complexity of the sensors and the drones needed to carry them,
Right.
tends to be the more expensive option.
Okay.
So entry-level systems can start around $20,000,
Mm.
but professional-grade setups can easily exceed $100,000.
Okay, that's quite a range.
It is.
What about RTK? Is it a bit more budget-friendly?
Yes, generally speaking, RTK is more accessible in terms of cost.
Okay.
You're essentially adding an RTK module to an existing drone,
Okay.
which can add a few $1,000s to the total cost.
So while both LiDAR and RTK offer significant benefits for construction projects, the cost can be a deciding factor.
Yeah.
For large-scale complex projects with difficult terrain, LiDAR might be worth the investment.
Mm-hmm.
But for projects on relatively flat, open sites where precise measurements are key,
Right.
RTK could be a more cost-effective option.
Exactly.
Understanding your project needs and the long-term benefits of each technology will help you decide which one is the right investment for you.
Absolutely.
Well, I think we've covered a lot of ground in this first part of our LiDAR versus RTK deep dive.
We have.
We've learned what each technology is, how it works, and the key differences in their applications and costs.
Mm-hmm. Welcome back to our exploration of LiDAR and its revolutionary role in construction.
I'm still amazed by everything we talked about in the last part. The way LiDAR can create those detailed 3D models and essentially see through solid objects, it's incredible.
Yeah,
But I'm curious to dig a bit deeper into the practical applications.
sure.
How exactly is LiDAR being used to make construction projects more efficient and effective?
One area where LiDAR really shines is in pre-construction planning and site analysis.
Mhm.
You see, traditionally, surveyors would have to spend weeks, sometimes months, manually measuring and mapping a site.
Right.
It was a very time-consuming and often labor-intensive process.
Right. And with LiDAR, we're basically replacing those boots on the ground with lasers in the sky.
Exactly.
Huh?
LiDAR allows us to capture a huge amount of data
Mm.
about a site incredibly quickly.
Okay.
And because of the precision of those 3D point clouds,
Uh-huh.
we're getting a level of detail that was simply unimaginable with traditional methods.
Okay, so we're talking about faster data collection and incredible detail.
Right.
But can you give us some concrete examples of how this LiDAR data is being used in pre-construction planning?
Sure.
What kind of insights can it provide?
Imagine you're planning a new highway project.
Okay.
With LiDAR, you can create a highly accurate digital terrain model of the entire proposed route.
Mm-hmm.
This model will show you things like elevation changes, the locations of existing structures and utilities,
Okay.
and even the density of vegetation along the corridor. All of this information is crucial for making informed decisions about the best route alignment,
Uh-huh.
the placement of bridges and tunnels,
Okay.
and even the design of drainage systems.
It's like being able to see the entire project laid out in front of you before you even start moving any dirt.
Right.
This level of foresight must be invaluable for project managers.
Absolutely.
Yeah.
And it's not just about seeing what's there.
Okay.
It's about what we can do with that information.
Right.
For example, LiDAR can identify potential geological hazards,
Okay.
like unstable slopes or areas prone to landslides,
Mm-hmm.
which might not be visible during a traditional site survey.
Oh.
This early identification can help to prevent costly delays and even ensure the long-term safety of the project.
Wow, that's a great example of how LiDAR can not only save time and money,
Yeah.
but also potentially save lives.
Precisely. And another key advantage of LiDAR is its ability to accurately estimate volumes.
Okay.
For example, if you need to calculate the volume of earth to be excavated for a foundation, or the amount of fill material needed for a road embankment.
Right.
LiDAR can provide extremely precise measurements.
Okay.
This level of accuracy is crucial for project budgeting and resource allocation.
It sounds like LiDAR is taking a lot of the guesswork out of these critical pre-construction decisions.
It is.
And it's not just about the initial planning stages, is it?
Right.
How is LiDAR being used during the actual construction process to manage and optimize projects as they progress?
That's a great question because LiDAR doesn't stop being useful once construction begins.
Okay.
In fact, it becomes even more valuable during the construction phase.
Okay.
One key application is in-progress monitoring.
Mm-hmm.
By regularly scanning the site with LiDAR,
Okay.
we can create a series of digital snapshots that show exactly how the project is evolving over time.
Okay.
And these snapshots can be compared to the original design plans
Right.
to
Yeah.
track the progress of various construction activities,
Okay.
such as earth-moving foundation work
Right.
and the placement of structural elements.
So it's like having a constantly updated digital twin of the construction site
Yeah.
that allows project managers to see exactly what's happening on the ground and how it aligns with the original plans.
Exactly. And because LiDAR provides such precise measurements,
Mm-hmm.
we can track progress with a level of detail that was previously impossible.
Okay.
We can see if things are on schedule,
Right.
identify potential bottlenecks,
Mm-hmm.
and even detect minor deviations from the plans before they turn into major problems.
That level of real-time insight must be incredibly valuable for keeping projects on track and avoiding costly delays.
Absolutely. And this continuous monitoring capability also leads to the creation of highly accurate as-built models.
As-built models. Can
Yeah.
you explain what those are and why they're important?
Of course, as-built models are essentially digital replicas of the completed construction project.
Okay.
They show the exact location and dimensions of all the structural elements, utilities,
Mhm.
and other key features. They're essentially digital blueprints that reflect the as-built condition of the project,
Okay.
rather than just the design intent.
I see. So these as-built models are like digital records of exactly how the project was built, which
Yeah.
would be incredibly useful for future maintenance renovations
Yeah.
or even legal and insurance purposes.
Exactly. They provide a comprehensive record of the project that can be accessed and referenced at any time,
Right.
which is invaluable for facility management and long-term decision-making.
It's fascinating to think about how Lidar is not only transforming how we build things,
Yeah,
but also how we manage and maintain those structures over their entire lifespan.
it is.
It's like having a digital time capsule that captures every detail of the construction process
Right.
and provides a roadmap for the future.
That's a great analogy.
And as LiDAR technology continues to evolve,
Mm-hmm.
we can expect those digital time capsules to become even richer and more insightful,
Absolutely.
offering even greater value to the construction industry.
Yes.
Speaking of evolution, are there any emerging trends or advancements in LiDAR technology that have you particularly excited for the future of construction?
Oh, absolutely. One of the most exciting trends is the increasing affordability and accessibility of LiDAR systems.
Okay.
As the technology matures, the costs are coming down,
Right.
which means it's becoming a viable option for a wider range of projects,
Okay.
even smaller scale construction.
That's great news.
It is.
So we're going to see even more widespread adoption of LiDAR,
Yeah,
leading to even greater efficiency and innovation in the construction industry.
exactly. And it's not just about the cost.
Okay.
We're also seeing a lot of innovation in the LiDAR sensors themselves.
Uh-huh.
They're becoming smaller, lighter, and more energy efficient,
Right.
which means they can be mounted on a wider variety of drones,
Okay.
making them even more versatile and adaptable for different project needs.
So we're getting more powerful LiDAR systems in smaller and more affordable packages.
Yeah,
That's a winning combination.
absolutely. And it's not just about the hardware.
Okay.
There are also exciting advancements in the way LiDAR data is processed and analyzed.
Right.
We're seeing the integration of artificial intelligence, AI, and machine learning, ML algorithms,
Uh-huh.
that can automatically identify and classify objects in the 3D point clouds,
Okay.
extract meaningful insights,
Right.
and even predict potential problems before they occur.
So we're not just getting better at capturing the data, we're
Mm.
also getting smarter about what we do with that data.
Exactly.
That's really where the power of LiDAR comes into play.
You got it. We're moving beyond simply creating 3D models.
Right.
We're using those models to make better decisions, improve efficiency, enhance safety,
Mm-hmm.
and ultimately build better structures.
It sounds like LiDAR is really pushing the boundaries of what's possible in construction.
It is.
It's not just a tool, it's a catalyst for innovation and a whole new way of thinking about how we build the world around us.
Yeah, I agree.
But before we get too carried away with the wonders of LiDAR,
Okay.
I want to make sure we circle back to RTK and give it its due diligence.
Of course.
Welcome back, everyone. We're wrapping up our LiDAR versus RTK comparison by taking a closer look at RTK and its role in construction.
Right.
We've spent a good amount of time on LiDAR and its 3D modeling capabilities,
Yeah.
but now...
That's pretty cool stuff.
Oh, it is! But now let's shift our focus to RTK and how its pinpoint accuracy is making waves in the industry.
It's all about that precision.
Yeah.
Pinpoint accuracy is key.
It is, and we touched on a few of the tasks that it's good for in the first part. but
part one.
yeah, can you elaborate on some real-world scenarios where that centimeter-level accuracy is absolutely critical?
Sure. So one area where RTK really shines is in creating these highly accurate orthomosaic maps.
Okay.
These maps are basically aerial photographs that have been stitched together and geometrically corrected to create a distortion-free, highly precise representation of the site.
So it's like having a giant, perfectly scaled blueprint of the entire construction site.
Yeah, it's like having a giant map.
And it's not just a pretty picture, it's a highly accurate, measurable representation of the site.
Exactly.
That must be incredibly useful for a variety of tasks throughout the construction process.
Absolutely. And because RTK provides such accurate positioning data,
Hmm.
those orthomosaic maps could be used for everything from planning and design to monitoring progress and even generating as-built documentation.
And I imagine that level of accuracy is also essential for things like surveying and boundary mapping,
Oh, yeah.
which can be incredibly time-consuming and prone to errors using traditional methods.
Definitely. Traditional surveying can be a real headache, especially on large or complex sites.
Yeah.
But with RTK-enabled drones,
Mhm.
we can survey a site much faster and with a much higher degree of accuracy. Think of it this way. Instead of surveyors trekking through rough terrain with heavy equipment,
Right.
we have drones zipping around gathering precise data and creating digital maps in a fraction of the time.
Wow, that's quite a visual. And I imagine that efficiency translates to some pretty significant cost savings as well.
RTK is helping to streamline surveying and mapping operations. which is a huge win for construction companies in terms of both time and money.
Okay, so we've talked about orthomosaic maps and precise surveying. What other construction tasks benefit from RTK's centimeter level accuracy?
Another crucial application is in volume calculations,
Okay.
whether you're measuring stockpiles of materials like gravel or sand,
Right.
or tracking the amount of earth being moved during excavation.
Okay.
RTK provides the precision needed to generate accurate volume estimates.
That makes sense. Accurate volume data is essential for everything from managing resources and tracking progress to ensuring accurate billing.
Exactly. And that precision can also help to reduce waste and optimize material usage,
Right.
which benefits both the project budget and the environment.
Absolutely. So we've talked a lot about the specific applications of RTK,
Yeah.
but I'm curious to hear your thoughts on the bigger picture. How do you see this technology impacting the construction industry as a whole?
I believe RTK, along with other drone-based technologies, is driving a major shift towards digitalization in the construction industry.
Yeah.
We're moving away from paper plans and manual measurements
Right.
to digital models, data-driven decision-making,
Huh.
and increased automation.
That's a pretty significant transformation. What are some of the key benefits you see emerging from this shift towards digital construction?
Well, as we've already discussed, one of the biggest benefits is improved efficiency.
Right.
By streamlining tasks like surveying, mapping, and progress monitoring,
Right.
RTK is helping to reduce the time and cost associated with those activities.
And time is money in the construction world?
It is.
So those efficiency gains can significantly impact the overall project budget.
Absolutely. But in addition to efficiency, we're also seeing improvements in safety.
Okay.
By using drones to collect data, we can reduce the need for workers to be in potentially hazardous environments, such as busy construction sites or difficult-to-access areas.
That's a crucial point. It's not just about doing things faster and cheaper, it's about doing them safer.
Exactly. And that focus on safety is a major driver of the adoption of these technologies across the industry.
It's amazing to think about how far construction technology has come in just a few short years. We've gone from relying on tape measures and hand-drawn blueprints to having drones create these incredibly detailed digital models and maps with pinpoint accuracy.
It really is a remarkable evolution,
Yeah.
and I think we're just scratching the surface of what's possible.
Yeah.
As these technologies continue to evolve and become even more accessible, I believe we'll see even more innovation and transformation in the construction industry.
Well said. It's definitely an exciting time to be in construction, and I can't wait to see what the future holds. And on that note of technological optimism, it's time to wrap up our Lidar versus RTK deep dive. We've explored how both of these incredible technologies are pushing the boundaries of precision mapping, each with its own set of strength and applications. Lidar, with its ability to create those detailed 3D point clouds, is revolutionizing site analysis, pre-construction planning, and progress monitoring, giving us an unprecedented level of insight into the terrain and the structures we build upon it. RTK, on the other hand, is the champion of pinpoint accuracy, providing that centimeter-level precision that's so critical for tasks like surveying, mapping, and volume calculations. As you navigate the ever-evolving world of construction technology, remember that the key is choosing the right tool for the job. Whether you opt for the 3D depth of LiDAR or the pinpoint precision of RTK, these technologies are empowering us to build smarter, safer, and more efficiently than ever before. So the next time you find yourself on a construction site, take a moment to appreciate the incredible power of these technologies and the impact they're having on the way we design, build, and manage the structures that shape our world. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.